The quadratic formula, what is it? What does it do? What's the purpose of it? Here we go. So if you open up pretty much any textbook, that's what it's going to say for the quadratic formula. Now, look at it this way. Let me make up a random equation. Let me make up a random function, okay? Something like this. This here is a function. And if you were to graph it, it makes a certain picture. If you were to go to Desmos, and if you were to type this in, here is roughly what you would see. It would look something like this. And then if you were to take your fingers and if you were to click there and there, these locations would be -6 and +2. If you don't believe me, check this out. So it looks something like this. Now, these points here, they have a special name. Those are what we call, they're called the x-intercepts. Perhaps you've heard of them before. Yes, the x-intercepts. Now, is there a way for us to discover the x-intercepts without graphing? What if we don't have time to go to Desmos or to graph things by hand? How can I find x-intercepts like this without graphing? There are many ways, but some of the popular ways are as follows. One popular method, I'll write it here. One popular method is to employ factorization. If I were to take this here, if I were to factorize this, watch what would happen. So let me write this down here somewhere. X squared plus 4x minus 12. Maybe you have seen this before, this thingy. So let's factor this here using this method. And by the way, this method, it's not the most proper of methods, but it works, okay? So what your teacher would probably tell you would be something like, hey, multiply this number and this number, put that up here, take this number, put it down there. Now find two numbers that multiply to here, but they add to there. What are the two numbers? Well, they are 6 and -2. So what do I do with these numbers? Well, I use this and I factor it into the following, okay? Something like that, right? But what if I go equals 0? Equals 0. And then your teacher would say something like, set this equal to 0. And then they'd say, set this equal to 0. And then solve each of these two baby equations. So one of them is -6 and one of them is +2. So if you notice these numbers, boom, they're right there. So anytime you do factoring, anytime you solve equations by factoring, what are you finding? You're finding the x-intercepts of that equation, right? Of that parabola. So that's one way of finding the x-intercepts, by factoring. What's another way? You guessed it. Another way to find the x-intercepts is to use the quadratic formula. Now the quadratic formula, which is the purpose of this video, it looks like this, but what does it need from us? It needs an A, it needs a B, and it needs a C. Where are my A's and B's and C's? Well, they're right here, watch. This is C, this is B, and the invisible one that's right there, that's A. So let me go through and write this again, but instead of A's and B's and C's, I'm going to use 1, 4, and -12. So if you fill out the quadratic formula, it should look like this. Let's clean this up just a little bit. So this is what it gives you. So that's 4 squared is 16. Negative times negative is positive. Now what's 16 plus 48? Now we can square root the 64. So now I have two different cases. I have one with a plus and then one with a minus. And then up here, -4 plus 8 is 4 divided by 2 is 2. And then -4 minus 8 is -12 divided by 2 is -6. So this tells me that x equals 2 or x equals -6. And notice that these numbers, They popped up yet again because these numbers are the x-intercepts of this parabola. You see what I'm saying? So the x-intercepts, they're really popular. Everyone wants to know where the x-intercepts live. What are some of the ways of finding their location? One way is to graph on Desmos, or you can do it by hand as well, using a table of values. What's another way of finding x-intercepts? You can use the idea of factoring, where you do this business here, and the numbers that you get are the x-intercepts. And this video was dedicated toward the quadratic formula. So if you take the a, b, and c values and you feed them into the quadratic formula, what will you get? You will get the x-intercepts of whatever equation you began with. Now, a couple of comments before I let you go. Comment number 1. Do your x-intercepts always end up nice, pretty numbers like this? No. Sometimes you get weird things like, I'm just making this up. Sometimes you get really weird numbers like this, right? Plus or minus. Sometimes you get really weird numbers like this, and those will be some crazy decimals. But whether the answers are nice or not nice, it doesn't matter. We are accomplishing the same thing. We are finding the x-intercepts of the parabola. Will you always have x-intercepts? No. Sometimes you'll run into this. Watch. Sometimes you'll do your math and it says something like this. Check it out. You've probably seen this before. Sometimes when you do the quadratic formula, you get a number that's negative. And that, your teacher would be like, hey, NRS, no real solution. And the reason for that, the reason sometimes you have a negative in the square root is because the picture that you're trying to play with would be something like this. Watch. You see, sometimes you have a parabola that it doesn't have any x-intercepts. Sometimes you have a parabola like this one, it never crosses the x-axis, or maybe like this. That one doesn't cross the x-axis. So anytime you try to use the quadratic formula for a graph that looks like this or like this, you can guarantee yourself that when you do the quadratic formula, you're going to get a number inside the square root that is negative. Okay, so that's just the general breakdown concerning the quadratic formula.